This is Ramarao sir from IIT Rajendra Nagar. Today I will going to explain the concept of dual nature of radiation and matter. It is a very important for the JEE mains and advanced level also. Compulsory one question will be coming on JEE mains. JEE mains scale one question will be coming, and advanced scale mixed concept is asking in case of an advanced. Okay. Dual nature of radiation and matter. So, in this lesson particularly we should have to discuss about the photoelectric effect and de Broglie wavelengths and various methods. See, before going to that, first I have to explain the concept of the photon. Okay. Quantum theory, Planck's quantum theory, Planck's quantum theory. According to this, the light is propagating in the form of a photons like this. The light is propagating in the form of a photons like this. The light is propagating in the form of a photons. So, each photon possessed some amount of energy, that is each photon produces some amount of energy. So, the energy of the photon is direct proportional to the frequency. Suppose if a photon has a large amount of energy, then it can be vibrates with a large frequency. If the photon has a small amount of energy, then it can be vibrates with a small amount of frequency. That means that each photon possesses the respective of the energy C1, E1, E2, E3, E4 and E5 like that and so on. This is a propagation of the light in the form of an photons. Is it clear? Each photon has some amount of energy. The energy of the photon is direct proportional to its frequency. That is E is direct proportional to what is that? E is direct proportional to nu. E is equal to h nu, where nu is called as the frequency of vibration of the photon and h is called as a Planck's constant, where h is called as a Planck's constant. Planck's constant, its value is x value, h value is 6.62 into 10 to the power of minus 34 joule second. Okay. And when this photon is instant on certain types of the metals, it can be exerted the force and it can be exerted the pressure, and due to that what happening is there, let us say here this photon is instant certain types of the metals, it can be produced what is that, it can be exerted the pressure and force also. Next year see, the photon would be traveled, the photon can travel, this is a photon, the photon can travel with a velocity of light, that is c is equal to 3 into 10 to the power of 8 meter per second. The photon can be traveled with a velocity of light, that is equal to 3 into 10 to the power of 8. Okay. The photon travel with the velocity of light, that is 3 into 10 to the power of 8 meter per second. Next, the photon possesses the energy and the photon possesses the momentum also. When a photon is traveling with the velocity of light, then what happening is that it is possessed with the mass also. Suppose consider a photon, right, which has some amount of mass and it is traveling with velocity of light c, and it is possessed some amount of energy E. Okay. So, the energy of the photon can be defined as E is equal to what is that? E square, E is equal to m into c square. According to the Einstein energy equivalent equation, the energy of the photon can be written as E is equal to mc square. So, from this what I am writing, see, that is E is equal to m into c I am writing, c take this side, that is E upon c is equal to m into c. So, what is the c? C nothing but a velocity of photon, and m is nothing but a mass of an photon. Therefore, the mass of an photon is given by what is that? The mass of an photon is given by E is equal to what is that? the mass of an photon is given by, what is the mass of an photon? M is equal to what is the M? M is equal to E upon C square. This is a mass of an photon, and the product of mass and velocity is called as, what is this called? This is called as the momentum of an photon. Momentum is given by P is equal to M into C is equal to, what is that? M into C is equal to E by C. E by C. E by C is called as a, what is this called? Momentum of the photon. The product of mass and velocity is called as momentum of photon. This E is writing H nu upon C. So our P is called what I am writing, but C is called nu lambda is already known. C is called nu lambda. Okay, nu by C is equal to, what is the nu by C? Nu upon C is equal to 1 upon lambda. That is equal to, P would be is equal to, what is the value of P? H upon lambda. So from this, lambda is equal to H upon P. This is called as a wavelength of the photon, or P is called, this is, I am writing in the form of momentum, that is H upon M into C is called as a wavelength of the photon. When energy is, when a photon is traveling with certain velocity, it can be possesses some amount of the mass. So the mass of the photon is given by this much, M is equal to E by C square. Is it clear? Next, the momentum of the photon is given by P is equal to the product of mass and velocity is called as the momentum of photon. That would be is called E by C. E is nothing but H nu upon C. Okay, right? That is where C is called nu lambda is already known. Where nu is called as the frequency of vibration of the photon. That is called nu by C is called, nu by C is called 1 by lambda. This value substitute here. Then what you will getting? P is equal to H by P, that is equal to, sorry, H by lambda, because of 1 by lambda is equal to C by nu. Therefore lambda is equal to H by P. This much wavelength it would be associated. The wavelength associated by the photon when it is traveling with velocity of light would be equal to, what is that? Lambda is equal to, what is the lambda? Lambda is equal to H upon MC, where C is called as the velocity of light and M is nothing but a mass of a photon. So when a photon is traveling with the velocity of light, it can be possessed mass, but the rest mass of a photon is equal to 0. When the photon would be at rest, that means when the photon would be equal to rest, when velocity of the photon will be 0, its mass would be also 0. M photon is also 0. M photon is also 0. That means the rest mass of the photon would be is equal to 0. Okay, this is called as a, what is this called? Quantum explanation. Maxwell was given some assumptions like this. Okay, when a photon is traveling with velocity of light, it possesses some amount of mass. When it would be at rest, so the, what is that mass of the photon would be is equal to 0. Next, see the properties of photons. The photon can be exhibits as the following properties. So what are they? See here. When a photon is traveling with a velocity of light, photon means what is that? This is a, it can be produce electric field as well as magnetic field. That means electromagnetic radiation only photon means. The combination of the photons is called as an electromagnetic radiation. Okay, when a photon is traveling, that means the combination of the photons is called as a photon beam. When a beam of photon is traveling with a velocity of light like this, when with a velocity of light, c is equal to 3 into 10 to the power of 8 meter per second. Meter per second. It could be exerted the pressure also. It could be exerted the pressure also, and it could be exerted the, what is that, force also. When a photon is going to incident, or when a photon radiation or light radiation is going to incident on certain types of the metals or surfaces, it would be exerted the force on the surface of the walls. Okay, it would be exerted the force on the surface of the wall. Suppose when the light radiation is going to incident like this, going to incident on the metal surface, what happening is there, it would be exerted some amount of force, and it would be exerted also some amount of the pressure. Okay, when the light radiation is going to like this, suppose consider a torch. Do you know torch? The torch would be like is there, this is a torch. Okay, this is a torch, this is a torch like this. Suppose consider a torch light like this is a torch light. When the switch is on, when the switch is put on, when switch is put on, what happening is that the torch light would be emits the light radiations like this. Okay, the torch light would be emits the light radiations. So this light radiations is consisting of how many number of photons? We don't know, let's say n. When the radiations are going to incident on certain types of the surfaces like this, when these radiations are going to incident on the certain types of the surfaces like this, then what happening is there, they will be experiences some amount of the force. Okay, they will be experiences some amount of the force. They would be experiencing some amount of the force on the surface of the walls. Is it clear? On the surface of the walls. Therefore, like this, they would be experiencing some amount of the force. Therefore, the energy of the photon is given by E is equal to, what is that? M into C square. Is this clear? That energy would be experiencing the force on the wall. How much amount of the force has to be experienced on the wall? See, due to the how much amount of the force they would be experienced on the wall, that is we should have to calculate now. Okay, right, this is a torch light. Okay, so delta P is equal to the change in moment, the initial momentum of the photons would be equal to, let's say, P1 or pressure P1. When they are going to instance on this, what happening is there, the pressure has to be changes Pf. These photons are traveling with the velocity of light, Therefore, the change in momentum can be written as delta P is equal to P upon C is already knows. That means there is no have any angle theta. There is no have any angle theta. Therefore, the change in momentum is given by P upon C. The change in pressure is given by P upon C is already knows. Next, see, suppose when a photon light is going to incident on certain types of the walls like this. So this is the horizontal direction. Okay, when a photons are going to incident on the wall, making some angle theta here, if they are reflected with the same amount of velocity at this point like this, same amount of velocity making same angle theta, then how much amount of the force they would be exerted per second? The amount of force exerted by the photons per second is given by how much here? See, here see, this momentum can be resolved into two rectangular components, say beta, that is this direction of P would be like is there, okay, which is make some angle theta. So this angle also would be theta ho jate. Okay, P can be resolved to rectangular component. So along the direction क्या हो जाता है बोलो, along the direction P cos theta at this point, P cos theta, this is a P cos theta, P cos theta. Next, along the direction is a P sin theta, P sin theta. Okay, at this point they would be makes angle with the horizontal, they would be exerted like this P sin theta, and it is also along this direction. So you can see, you can see along the direction of angle P cos theta हो जाते, ठीक है. Once again I am drawing, see here, we have to take here, see, along the direction due to this P cos theta, other than direction of angle, this is a P sin theta. This is. Next here, see, when it will be reflected in the same direction, the same velocity or with the same momentum like this P and P. Okay, in the reflecting direction, what happening is there, in this direction P cos theta हो जाता है. Okay, in this direction क्या हो जाता है बेटा, P sin theta. So P cos theta only responsible, this component only responsible the force experienced on the walls. Okay, so what is that? The change momentum is equal to given by what is that, P cos theta minus of minus P cos theta. Cos theta would be equal to क्या हो जाता है बोलो, that is equal to 2p into cos theta, change momentum, 2p into cos theta, 2p into cos theta. Okay, the force experienced is given by what is the force experienced? What is the force experienced? The force experienced by the photon on the walls is given by F is equal to, what is that, 2 into delta p, 2 into delta p into cos theta. Because of force, what is the force? F is equal to, according to Newton's second law of motion, dp upon dt, where dt value second per second. Okay, so this also you can take delta p and this also you can take delta p. वो क्या हो जाता है, डेल्टा पी हो जाता है, वो क्या हो जाता है, डेल्टा पी, इसमें भी वो भी डेल्टा पी है, वो भी डेल्टा पी है, वो भी डेल्टा पी है. These two gets cancelled out, they could not be affected on the values. Okay, F is called dp by dt, where dt value taken per 1 second I have taken dp value. dp value is taken as 1 second here, dt value is taken 1 second here like this. Okay, this is a 1 second. Therefore, this should be is equal to delta p into cos theta, that is 2 into delta p cos theta. Therefore, the force experienced by the photons on the walls is given by, what is that, 2 into p upon c into cos theta. This much amount of the force they would be exerted by the photons. Okay, this much amount of the force they would be exerted by the photons on these walls. Is it clear? I hope that you maybe understood this concept. The force experienced by the photons when a light radiation is incident on certain types of the surfaces, it would be experiences some amount of the force. So the force experienced by the photons on the walls is given by, what is that, F is equal to 2p into cos theta. F bar is equal to 2p into cos theta. Is it clear? Okay. Next see, next, intensity of a photon or light radiation. Intensity of light radiation. What is an intensity of light radiation? See, what is an intensity of light radiation? So the amount of energy transmitted per unit area per unit time is called as the intensity of a light radiation. Suppose consider a surface here beta, this is surface ऐसे है, this is surface. Okay, when the torchlight is focused like this, when the torchlight has to be focused like this, a torchlight, when the torchlight is focused like this and the switch is put on, this is put on, the switch is on, then what happening is that the light radiations are propagating like this. The light radiations are propagating, a beam of light radiations are propagating in the surface area. Let's say this area would be is equal to 8. So these all light radiations are having some amount of energy, that is the energy is transmitting this surface area. The energy is transmitting the surface area. Let's say this is A. In T is equal to, what is beta? T is equal to 1 second. Okay, the amount of energy transmitted, the amount of energy transmitted through a surface per unit time per unit area is called as the intensity of light. That would be I is equal to E upon the amount of energy transmitted. The amount of energy transmitted per unit time per unit area is called as the intensity of light. That is I is equal to E upon A into T is called as what is this called? Intensity of light. The intensity of photon or intensity of light, I is equal to E upon AT. So from this it is very clear that this is what I am writing. See, E is called H nu upon A into T. This is also what I am writing. See, H nu HC upon lambda into A into T. So the intensity of the photon can be written as in the form of, in different forms like this. This is called as an intensity of photon, where E by A is called as energy by time. Energy by area is called as what is that? Energy by time is called as the power. P is equal to the power experienced by the photon on this wall is given by I is equal to, what is that? where E by T is called as the power, that is power upon power into what is that, power upon A only, power upon area, power upon area only, that is called power P upon area A. This is what I am writing, I is equal to P upon A. P is called as the power upon area A. Suppose if the source has in the form of a point, suppose a point source, this is a point source, it can be emits the light radiations in all directions like this. This is a source, the source can be emit the light radiations in all directions like this. It can be emit the light radiations in all directions. Okay, this is a point source. If the point source can be emit the light radiations in all directions, it has a radius r. This area would be, we can written as I is equal to P upon 4 pi r square. A value is a 4 pi r square, where A is equal to, what is the A? A is equal to 4 pi r square. Okay, is it clear? 4 pi r square. Therefore, if the intensity of light is more, the number of photons emitted is more. If the intensity of light is small, the number of photons emitted is also small. That means if the light is consisting of more than large number of photons, it can be emits large amount of current. Okay. If the light consisting of small number of photons, it can be emits the small amount of the current. Okay, right? So it is very clear that what is that, the intensity of the light I am writing in the form of I is called P upon 4 pi r square. That is, I is direct proportional to 1 by r square into electric current also. If the light ray consisting of more number of photons like this is a ray of light. The ray of light is consist more number of photons like this, more number of photons. Its intensity is more. It can be emit a large amount of current. If the light ray is consisting of small number of photons like this, where intensity is a small. If the intensity is decreased, simply electric current also decreases. When the intensity is increased, automatically electric current also increases. Is it clear? Okay. See, based on the concept on problem C. Suppose consider a point source. This is a point source, has a radius 2 meters. Okay. And it can be produced, the electric current of I1 is equal to, it can be produced an electric current of I1 is equal to 18 milliamps. Okay. If the point source of the radius has to be increased like this, where R2 is equal to 6 meters. Let's take this, I have taken 2 meters. Okay, this is 2 meters only. It can be produced how much amount of the current? It can be produced, the current would be is equal to, what is that? I1 is equal to 18 milliamps. If the radius has to be increased 6 meters, how much amount of the current this point source would be produced? That was the question. Find the current produced by the second source. I shown in figure like this. This is a source, but its radius has to be increased. How much amount of the radius has to be increased? R2. Okay. In this case, a point source, 2 meters radius point source produces the 18 milliamps current. Okay. If the radius has to be changed from 2 meters to 6 meters, how much amount of the current it can be produced? That is, we should have to calculate now. Already you know what is that, the intensity of photon I is direct proportional to I. That means intensity is increase, current also increase is already know. Current I is also increase. But I is what is that? I value is P upon 4 pi R square, where power is remains constant only. Your P1 is equal to constant, your P2 also would be constant. P2 also constant. I is the inverse, I is equal to P upon 4 pi R square. From this very clear that I is direct proportional to 1 by R square. From this I1 upon I2 would be is equal to R2 upon R1 of whole square. Okay. We have to calculate this I2 value, and I2 is equal to, what is the value of I2? I2 is equal to R1 upon R2 of whole square into I1. It's the value of I1. Therefore, the value of I2 would be equal to, what is I2? I1 value was given 18 milliamps into, what is that, R1 upon R2? R1 value was given 2 meters. 2 meters upon R2 value was given 6 meters. This is 6 meters was given. Okay, meter gets cancelled out. 2 ones are 2, 3s are, that is I2 is equal to 18 milliamps upon, this is a whole square, no, whole square, upon 9 ones are 9 twos are, that is equal to 2 milliamps current. 2 milliamps current it can be produced. Is it clear? That means the intensity of light is direct proportional to, what is that, emission of the photons. The emission of the photons is more, the current would be more. When the emission of the photons is small, the current would be small. So based on the concept, a point source has a radius 2 meters, it can be produces the current of 18 milliamps. Okay, with the same point source of the, what happening, radius has to be increased 6 meters. So how much amount of the current it can be produced means, so I2 is equal to what is the 2 milliamperes current it can be produced. Is it clear? Is it clear or not? Okay. Next, see. Next, photon flux. Photon flux. Photon flux pi. What is a photon flux? Photon flux can be defined as pi. Pi is equal to the ratio of intensity of photon to its energy. The ratio of intensity of photon to its energy is called as a photon flux. Okay, it is defined as a pi. Pi is equal to E of I upon E. But E value also already know what is the E. But E is equal to H nu. That is called Hc upon lambda. What is the value of I? I is equal to P upon A or E upon A into T. P is equal to E upon AT. Therefore, these two values are substituted in the above equation. Then what you will get in the form of a intensity and pressure, in the form of a intensity and pressure, see here. Therefore, pi is equal to, what is the pi? Pi is equal to, I value is P upon A. P upon A is whole divided by E value is there, E. Okay, E value is there. That is, pi is equal to P upon A into E. A into E. Or where P is equal to, what is the P? P is equal to pi into A into E. This is a, what is that, pressure in the form of photon flux, area of the cross section, and energy. Next, see, this is I am writing in the form of energy. That is, pi is equal to P upon A. That is what is the value of I? I is equal to E upon A into T is whole divided by E value. I am writing E. E. Is it clear? Therefore, the value of pi can be written as pi is equal to E upon E into A T, where E gets cancelled out. What is that? 1 upon A into T. is also called as what is that photon flux, or in the form of wavelength, what I am writing, see here, pi is equal to P upon A into E, that is equal to P upon A into SC upon lambda I am writing, that is the pi is equal to P into lambda upon A into HC. So these are the different forms of a photon flux. Photon flux means, what is the photon flux? The ratio of intensity of the light to its energy is called as a photon flux. It can be written as pi. Pi is called I upon E, pi upon E. So in the different forms of a photon fluxes are I have explained here. See, I, but I E is equal to H2, that is SC by lambda. I is equal to P upon A is already you know, or P is equal to E by T. Therefore, these two values are put in this above equation. What you will get? Pi is equal to P upon A into E. That is pi is equal to P upon AE. हो जाता है बेटा. So from this P is equal to pi into A into E. Okay. Or in the form of A and T only. Okay. Pi is equal to what is that? 1 upon AT. Next, in the form of wavelength, and what is that pressure?
స్టూడెంట్స్ కి ఎటువంటి డౌట్స్ ఉన్నా క్వశ్చన్స్ ఉన్నా ఎండ్ ఆఫ్ ది క్లాస్లో మీకు టైం ఇవ్వబడుతుంది. ఆ టైం ఇచ్చినప్పుడు మీరు నోట్ డౌన్ చేసుకున్న డౌట్స్ని మేము మీకు ఇస్తున్న నంబర్ని ఏదైతే స్క్రీన్ పైన స్క్రోల్ చేస్తున్నామో దానికి కాల్ చేసి మీరు అడగొచ్చు. ఒకవేళ ఫోన్ బిజీ వస్తే వేరే వాళ్ళు డౌట్ అడుగుతున్నట్టు అడతాము. దయచేసి స్టూడెంట్స్ చాట్ బాక్స్లో ఏమంటారు క్లాసులు వినకుండా ఎక్కువ చాట్ బాక్స్లో కామెంట్లు పెట్టడము దీనిపైనే ఉండకుండా దయచేసి మీ డౌట్స్ అన్నీ కూడా క్లారిఫై చేస్తారు డౌట్ సారు. దయచేసి మీరు ఏ డౌట్స్ ఉన్నా కానీ ప్లీజ్ నోట్ ఇట్ డౌన్, ప్లీజ్ నోట్ ఇట్ డౌన్. సో వాట్ ఎవర్ ద డౌట్స్ యు ఆర్ గెటింగ్ వైల్ క్లాస్ ఈస్ బీయింగ్ ఎక్స్ప్లెయిన్డ్, ప్లీజ్ నోట్ ఇట్ డౌన్ యువర్ నోట్స్. End of the class we are going to give you time. Please ask the questions at that time so that you have been clarified your doubts. Thank you.
Okay, see here, pi is equal to P into lambda upon A into SC. These are the different forms of a photon flux. Is it clear? Is it clear? Okay, see, next, see one problem, the energy of a photon. You know what is the energy of photon? See, when a photon is traveling with velocity of light, it possesses some amount of energy. No, E is equal to h nu, that is equal to SC upon lambda. That value you can put here. H value is how much? 6.62 into 10 to the power of minus 34 joule second into 3 into 10 to the power of 8 meter per second upon lambda value is into 10 to the power of minus 10 angstroms. This is you are getting in joules only. Okay. So in the form of electron volts, so already you know 1 electron volt is equal to how much? 1 electron volt is equal to 1 electron volt is equal to 1 electron charge is 1.6 into 10 to the power of minus 19 coulombs into 1 electron volts into 1. That is equal to 1.6 into 10 to the power of minus 19 joules. Okay, 1 electron volt would be equal to 1.6 into 10 to the power of minus 19 joules. But what is the value of 1 joule? 1 joule would be is equal to 1 joule is equal to 1 electron volt upon 1.6 into 10 to the power of minus 19 हो जाता है. वो ऊपर लगो इसमें लगो. Then what you will getting, see here, E is equal to energy of a photon would be 6.62 into 10 to the power of minus 34 into 3 into 10 to the power of 8 upon lambda in angstroms only, lambda into 10 to the power of minus 10 angstroms into joules we have converted in the form of electron volts, that is 1.6 into 10 to the power of minus 19 electron volts. Okay, right. Where 10 to the power of minus 34, 10 to the power of minus 34, 10 to the power of minus this is a minus 29, minus 34 gets cancelled out here, and the remaining term would be is equal to E is equal to 12,400 electron volts upon lambda in angstroms. So this is called as energy of an photon. Okay, is it clear? The energy of a photon or light radiation can be given as E is equal to 12,400 electron volts and upon lambda in angstroms. Is it clear? Okay, note down. So based on the concept on problem C, a light radiation consisting of wavelength lambda is equal to 4,000 angstroms. 4,000 angstroms. A light radiation is consisting of a wavelength lambda is equal to 4,000 angstroms. Then find its energy. Then find its energy. Find its energy in electron volts. We have to calculate the energy of the light radiation in the form of an electron volts. How can you calculate? See here, E value was given 12,400 electron volts and lambda was given in the form of an angstroms, that is equal to 4,000 angstroms. Now we have to calculate the energy of photon in the form of electron volts. Therefore, the energy of the photon is given by, what is the energy of photon? See, E is equal to 12,400 upon electron volts upon lambda in angstrom, that is equal to 4,000 diya beta, 4,000, 0, 0, 0, 0 gets cancelled out here. Okay, 4 ones are 4 threes are 4 ones are. Okay, here 10 is there. That is E is equal to 31.10, that is called 3.1 electron volts. The energy would be in the form of an electron volts is a 3.1 only. Is it clear? A light radiation consisting of a wavelength of lambda is called 4,000 angstroms. Then calculate its energy in the form of electron volts. So the energy in the form of an electron volts is given by 3.1 electron volts. Is it clear? Okay. Next, see. Suppose consider a photon. The photon has a certain height of h from the surface of the ground. Next problem, see. Suppose consider a photon. This is a photon. The photon has at a height of h. At a height of h from the surface of the ground, and it has some amount of the mass also. Okay, and some amount of energy E. Okay, here at this point it is vibrating with the frequency of f. Frequency of f. When it has to be fallen onto the ground, when it has to be fallen onto the ground, its frequency has to be changes f dash. Then find the change in frequency of the photon. Okay, when a photon is fallen onto the ground, find when a photon fallen on the ground, then find its change in frequency. Then find its change in frequency. Find its change in frequency. Change in frequency is how much? That is, we should have to calculate now. Okay, here initially the photon has at a height of h. Okay, when the photon would be at a certain height of h, it is possesses the potential energy also. When it is falling, it is possesses the kinetic energy also. The total amount of energy at this point would be equal to the total amount of energy at the ground. You should apply law of conservation of energy Uy plus Ki is equal to Uf plus Kf. Ui value is equal to mgh, that is mgh plus E is equal to, when it has to be fallen, its potential energy would be equal to 0. It is possessed only energy is equal to E dash only. Okay. Therefore, what is the value of E dash? E dash is equal to mgh plus, what is this? E is equal to h nu. Okay. This is what I am writing. The change in frequency h nu dash. H nu dash is equal to mgh plus h nu, or this is also writing hf dash, because of the frequency was given in the form of f dashes. That is called mg h plus h f. Is it clear? But the mass of a photon is given by, the energy of the photon is given by E is equal to h nu, that is equal to Sc upon lambda. Sc upon lambda, that is equal to mc square. mc square. Okay. Here what was given? M was given. M is equal to the mass of photon in the form of energy E upon c square ho jata. This is the mass of a photon. Therefore, h f dash would be is equal to, what is the value of M? E upon c square into gh plus hf. Therefore, f dash would be is equal to E upon c square into gh upon h plus hf upon h. So in this term, hh will gets cancelled out. Here also hh will get cancelled out. So the change of frequency f dash would be is equal to Eg upon c square plus f. Therefore, the change in frequency of photon would be f dash is equal to Eg upon c square plus f. Is it clear? Is it clear or not? Respond. Okay. A photon has certain height of h here from the surface of the ground, and it possesses some amount of energy. When it has fallen onto the ground, then find its change in frequency. इसका फोटोन का फ्रीक्वेंसी कितना चेंज हो जाते हैं वो भी निकालना पड़ता है. कितने फ्रीक्वेंसी, इतने फ्रीक्वेंसी चेंज हो जाते हैं. Is it clear? Okay. Next, see. Suppose consider a light radiation. A light radiation is operated at the power of P is equal to 200 watts. A light radiation used at the power of 200 watts, and it can be emit the number of photons per second. N by T is equal to 4 into the number of photons was given 4 into 10 to the power of 20 per second. Then calculate its wavelength. Wavelength कितने बेटा? Wavelength कितने हो जाता है? Wavelength कितने हो जाता है? Calculate wavelength. Write down problem. A light radiation is used at the power of 200 watts, and it can be emit the number of photon 4 into 10 to the power of 20. Then calculate the its wavelength lambda. Lambda कितने? वो भी निकालना पड़ता है. Okay, ठीक है. How can we have to calculate the wavelength lambda? The energy of the photon also already know. What is the energy of a photon? E is equal to h nu, that is equal to Sc upon lambda. This is only for single photon only. But if the light radiation consisting of a number of photons, the energy can be written as E is equal to, what is that? N into h nu upon, so N into h nu, that is called N into Hc upon lambda. Is it clear? This is applicable for n number of photons. So the power radiated in this given by, what is the power radiated? P is equal to E upon T. Energy by time is called as a power. Units are joules per second. Units क्या हो जाता है बेटा इसमें? Joule per second हो जाता है. That is called P is equal to N into Hc upon lambda. N into Hc upon lambda into T. Into T हो जाता है. Where this value was given, N by T was given, 4 into 10 to the power of 20. And SC values also already knows. We have to calculate the lambda. What is the value of lambda? Lambda is equal to Hc. What is the value of lambda? We have to calculate the value of lambda. Lambda is equal to N by T into Hc upon P. Is it clear? That is, lambda is equal to N by T value was given 4 into 10 to the power of 20. 4 into 10 to the power of 20. What is Hc value? H value was given 6.6 into 10 to the power of minus 34. C value is 3 into 10 to the power of 8. Upon power also given. What is the power? 4 into 10 to the power of 20. 4 into 10 to the power of 20 in meters you are getting. In meters you are getting. So this is, we should have to convert 1 meter is equal to, what is the, in the form of angstroms, lambda is equal to 3960 angstroms you are getting. Okay, you can simplify like this. 10 to the power of 20 will be gets cancelled out, and 4 also will get cancelled out. This you can simplify, you will get the lambda is equal to 3960 angstroms. Okay, this is a concept of a photon, and to solve the problems, different problems, when they are given in different forms. Okay, next see, the most important concept is a photoelectric effect. This is a very, very important for J mains and advanced level. Okay, photoelectric effect. Photoelectric effect. Photoelectric effect. What is a photoelectric effect? When a suitable wavelength or suitable frequency of electromagnetic wave radiation or electromagnetic wave is incident on certain types of the metals, so from the metal surface electrons are ejected. So this phenomena is called as a photoelectric effect. What is a photoelectric effect? See, suppose consider a metal. This is a metal. The metal is consisting of, what is that, positive and negative ions like this. Positive and negative ions, that means electrons and protons like this. Okay, electrons and protons like this are positive and negative ions. When a suitable frequency or suitable wavelength of light radiation is incident on certain types of the metals, so from the metal surface what happening is there, electrons are ejected here. From the metal surfaces electrons are ejected. Electrons are ejected. So this phenomena is called as a photoelectric effect. So it was first discovered by W. Smith, and Heinrich Hedge was discovered this phenomena in 1887. Okay. 1887, this phenomena was discovered by W. Smith and Hedge. Okay. So what is the internal mechanism for the emission of electrons? See here. So I am considering like this. The metal is consisting of a what is that, positive and negative ions. That means suppose consider this point I am taking like this. Here see, this is a positive ions. The metal is consisting of so many number of atoms like this. These are the so many number of atoms. This is a around the positive charge consisting of at the nucleus like this, electrons are revolving around it. This is a positive. Electrons are revolving around the nucleus like this. Electrons are revolving around the nucleus. Electrons are revolving around the nucleus like this. Okay. Electrons are revolving around the nucleus like this. Electrons are revolving around the nucleus. At the central part, positive charge has to be presented. This is a positive charge. Positive charge has to be presented at the center like this. This is a positive. This is also positive. And this is also positive and positive. Positive. The central part of the nucleus, positive charge has to be presented. Around the nucleus, what happening is there? The electrons are revolving with certain velocity v. The electrons are revolving around the nucleus like this. Okay. The electrons are revolving. The electrons are revolving around the nucleus like this. Electrons are revolving. Electrons are revolving around the nucleus in their specific orbits. In their specific orbit with a nuclear attraction force. Each electron would be revolving around in its orbit with a nuclear attraction force between the electron and the nuclear. Continuously, an attraction force will be presented. Due to this attraction force, these electrons are revolves around in its orbit. Is it clear? Around in its orbit. That means when a suitable wavelength or suitable frequency of light radiation is incident on this metal surface, what happening is that this incident energy can be utilized in two ways for an electron. Here see, this is a nucleus. Okay, this is a nucleus ZE or E. This is a nucleus here. See, this is a nucleus ZE. Okay. Around this, what happening is that an electron is revolving like this in a circular path, in a circular orbit with a nuclear attraction force. With a nuclear attraction force, the electron would be revolving. Then what happening is that away from this, what kind of the force will be acting? Centrifugal force Fu is equal to what is that? mv square upon r. Between them, what kind of the force will be presented? Electrostatic force of attraction Fe is equal to k into Ze square upon r square. This much electrostatic force of interaction would be presented between them. Okay, that means between the covalent bond has to be formed here. Between the electron and nucleus, covalent bond has to be formed like this. Okay. When a monochromatic electromagnetic light radiation or when a monochromatic light of suitable frequency or suitable wavelength is incident on this metal surface, that would be E is equal to H nu, that is equal to Hc upon lambda. So from this incident energy, some amount of energy has to be receiving this electron and it would be break up this bond. When it is break up this bond, then what happening is there? The electron would becomes very free. The electron would becomes free under the influence of a nuclear attraction force. It would be free. That means the bond has to be break up here. The nuclear bond, the covalent bond has to be break up here. When this bond has to be break up, then the electron will become free electrons. Free. That means this attraction force could not be affected on the electron. That means this amount of energy has to be utilized. First one is the work done. W is equal to pi. Then the remaining energy can be utilized to recoil from in its orbit. The electron has to be recoiled from in its orbit with maximum kinetic energy. K max is equal to half mv square max. With this maximum energy, the electron would be recoiled from its orbit. Okay, it was explained by whom? Smith and Hedge. Okay, when a suitable frequency and suitable wavelength of the light radiation is incident on certain types of the metals, so from the metal surface electrons are ejected. That phenomena is called as photoelectric effect. How would be the electrons are ejected and what is the internal mechanism means? This is the internal mechanism. When a suitable frequency or suitable wavelength of the light radiation is incident on this surface, so from the incident light some amounts of energy can be utilized to break up an electron from its nuclear attraction force. Is it clear? And the remaining energy can be utilized to recoil from in its orbit. So due to that, what happening is that the electrons are ejected here. See, in the previous case we have explained like this. Okay, in the previous case already we had explained. We have explained like this. See here. Okay, the electrons are ejected means simply they are not ejecting. When a monochromatic light of frequency nu is incident on the metal surface, electrons are ejected like this. Electrons are ejected like this. Electrons are ejected. How would be the electrons are ejected means? Due to this internal mechanism, the electrons are ejected. Is it clear? Is it clear or not? Okay. For recoiling of an electron, it must be it must be have the breakdown with the nuclear attraction force. So that's what it has to do, some amount of work to do. What is that? Break up the covalent bond. So that work function is this work is stored in the form of a function. This is called as a work function. What is that? Work function. Work function. What is a work function? It is generally denoted by pi or w as your wish. You can denote pi or w as your wish. I am denoting here pi. What is that? The minimum energy required for an electron to break up from nuclear attraction force is called as a work function. Work function. Or the minimum energy required for an electron to recoil from in its orbit is also called work function. So when it is break up from the nuclear attraction force, then what happening is that the electron would be recoiling, otherwise not possible. In this case it is not possible. When the electron could not be break up with the bond, it could not be emitted. When it would be break up with the bond, then it be emitted. Is it clear? That means, so for this purpose it has to done some amount of work. That work is called as a work function. The minimum amount of energy required for an electron to recoil from its orbit called as a work function. That is, it is denoted by pi is equal to w is equal to h nu naught, where nu naught is called a threshold frequency. That is, pi is equal to hc by lambda naught. This is also 12,400 electron volts upon lambda in angstroms. This is called a work function. Work function means the minimum amount of energy required for the electron to recoil from its orbit is called as a work function. Is it clear? Next, see, where nu naught is called as a nu naught. What is a nu naught? Where nu naught is called as a threshold frequency. What frequency? Threshold frequency. Threshold frequency nu naught. What is a nu naught? Threshold frequency. Threshold frequency means the threshold frequency. The minimum frequency required for an electron. This is an electron. The minimum frequency required for an electron to recoil from in its orbit with a nuclear attraction force. Okay. This is called as a threshold frequency. Threshold frequency means the minimum frequency required for an electron to recoil from its orbit is called as a threshold frequency, where a nu naught is called as, what is a nu naught? Nu naught is called as a threshold frequency. When the electron is revolving like this, it is possessing some amount of frequency. That frequency is also called as a threshold frequency. Or with that frequency, when the light of radiation incident on the metal surface, this frequency would be break up the covalent bond. Due to that, it can be recoiling. So this minimum frequency is called as a threshold frequency. Threshold frequency means the minimum frequency. The minimum frequency required of an electron to emits from in its orbit. from in its orbit. What is the minimum frequency required for an electron to emit from its orbit is called as what is this called? Threshold frequency. Okay. Next, see beta. Threshold wavelength. Threshold wavelength. It is denoted by lambda naught. What is the lambda naught? Threshold wavelength means the electron is revolving around the nucleus like this. After break up the nuclear attraction force, what happening is that the electron would be recoiling, okay, with certain maximum amount of wavelength. So this wavelength is called as a threshold wavelength. The maximum wavelength required for an electron to recoil from its orbit is called as a threshold wavelength lambda naught. Because of E is equal to h nu is already know, that is equal to Sc upon lambda naught. So this is you can take work function. That is work function W is equal to h nu naught, that is equal to Sc by lambda naught, or this is also E, energy of an photon. Okay. That means it has a minimum frequency means, so from this is very clear that nu naught is inverse proportional to 1 by lambda naught, where nu naught is a minimum, lambda naught is must be max. Okay. So the maximum wavelength required for an electron to recoil from in its orbit, or to eject from its orbit is called as what is this called? Threshold wavelength. The maximum wavelength required to an electron to emit from in its orbit, is called as a threshold wavelength. Okay, threshold wavelength. Next, condition for emission of an electron from their orbit. So what conditions are applicable here? See, conditions for an photoelectric effect. Conditions for photoelectric effect. What conditions are applicable for photoelectric effect? See here, it is very clear that what happening is that before instant energy, the electron is revolving around the nucleus like this. Okay, an electron is revolving with a nuclear attraction force. An electron is revolving around it like this. Okay. When a suitable wavelength or suitable radiation is incident on the metal surface, that is E is equal to h nu, that is equal to Sc upon lambda, then what happening is that the electron would be recoiling with a threshold frequency nu naught and threshold wavelength lambda naught is already know. Okay, threshold frequency nu naught and threshold wavelength lambda naught is already know, threshold wavelength lambda naught. So what conditions are applicable for the emission of the photoelectric effect? Here, see, when nu is greater than to nu naught, nu means frequency of instant light, nu naught is nothing but a threshold frequency of an electron. Condition C first, if nu is greater than to nu naught, when nu is greater than to nu naught, what happening is that the electron ejected, with the maximum kinetic energy or some amount of kinetic energy is equal to half m v square. the electron ejected with some amount of energy. In this case, the photoelectric effect will be takes place. If nu is greater than nu naught, the electron ejected with some amount of kinetic energy Ke, okay, then what happening is there in this case, photoelectric effect takes place. Photoelectric effect takes place when nu is greater than nu naught, the electron ejected with maximum kinetic energy. In this case, the photoelectric effect takes place. Next, if nu is equal to nu naught, that means the frequency of incident light, which is equal to frequency of rotation of an electron. In this case, the electron ejected from in its orbit with zero kinetic energy. When nu is greater than nu naught, in this case the electron ejected from its orbit is slowly emitting, but velocity is approximately equal to 0. It is ready to tends to eject from its orbit. It is ready to tends to eject from its orbit with a 0 kinetic energy. Okay. In this case also photoelectric effects also takes place. Next, third condition is if nu is less than to nu naught, that means the frequency of incident light is less than to frequency of the rotation of an electron. In this case, the electron, no photoelectric effect takes place because of in this case the nuclear attraction force ZE and E. In this case, the nuclear attraction force could not be break up in this case. Okay, when the nuclear attraction force could not be break up, in this case, how would be the electron ejected? It is not possible. No, possible nahi ho jata. Okay, when nu is less than nu naught, the covalent bond could not be break up with nuclear attraction force. So due to that, what happening is there? No photoelectric effect takes place. So in this case, photoelectric effect phenomena could not be applicable. So these are the conditions for the photoelectric effect phenomena. First one is, what is that? First one is nu is greater than nu naught, then the electron eject with some amount of kinetic energy. If in this case photoelectric effect takes place, if nu is equal to nu naught, electrons eject with 0 kinetic energy. Okay, if nu is less than nu naught, so in this case photoelectric effect does not take place because of nuclear attraction force could not be break up. In this case, neutron attraction force would be break up here, in this case nuclear attraction force will be break upping with the electron, it would becomes free, but kinetic energy K would be is equal to 0 here. So in the first condition, which is releasing with some amount of velocity here velocity would be is equal to 0, here velocity would be is equal to 0. In the first case, it would be possess some amount of velocity nu. Okay, so in the third case, what happening is that the photoelectric effect does not take place. Is it clear? Is it clear or not? These are the conditions for the applicable to form a photoelectric effect. Next, see, so what is the effect of an intensity? What is the effect of an intensity on photoelectric current? See, effect of an intensity of light on photoelectric current. Suppose consider what is that an atom. Here see, it was experimentally verified by the Smith and Hedge. Leonard was given the experimental verification. See here, there was considered what is that one arrangement. This is a one is the experimental arrangement of photoelectric effect. See, this is a cathode. And anode. They are placed in an evacuated tube. Across them, one voltmeter was connected like this. One voltmeter is connected. Across the voltmeter, one potential divider. This is called as a potential divider is connected with the help of variable source, negative, positive, negative, positive like this, and negative, positive, negative and positive like this. Okay, this is a variable source is connected. So this is called as a cathode and this is called as an anode. Here cathode is connected to here like this, cathode is connected to like this, and anode is connected like this. Okay, anode is connected across a variable resistor. When a suitable wavelength or suitable light radiation is incident from the metal surface like this, when a suitable wavelength or suitable frequency of light radiation is incident on the metal surface, what happening is there, from the metal surface electrons are ejected. From this metal surface electrons are emits. From the metal surface electrons are emits. When the metal surface electrons are emits, this emission of electrons are collected by this anode. When the electrons are collected with the anode, what happening is there, the current will be flows from the positive terminal direction to negative terminal direction. Okay, positive terminal direction to negative terminal direction, and the photoelectric current will be developed across them. If the intensity of the light radiation is incident, then what happening is there? When the intensity of light radiation is incident on the cathode, then what happening is there? When the intensity of light radiation is incident, what happening is there? The number of emission of electrons from the cathode is increased. When the number of emission of the electrons from the cathode is increased, so the flow of the photoelectric current in the circuit is also increased. Okay, so that is called as the effect of an intensity of light on photoelectric current. First case, it is also very important. Sometimes JEE Mains में पूछ रहे हैं, effect of intensity of light on photoelectric current. Effect of intensity, effect of intensity of light, effect of intensity, effect of intensity of light on photoelectric current, photoelectric current, photoelectric current, PEC means photoelectric current. Okay, here see, when the intensity increases, what happening is there? When the intensity is increased, what happening is that? When the intensity is increased, what happening is that? When the intensity of light radiation is increased, I is increased, what happening is that? The emission of electrons also increases. The emission of electrons increase. When the emission of electrons are increased, what happening is that? The photoelectric current is also increased. Okay, how would be the photoelectric current increase? How would be the photoelectric current increase? I is equal to what is that? I is equal to NE upon T, no? I is equal to NE upon T is already knows. I is equal to what is I? I is equal to the amount of energy emitted. I is equal to what is that? The amount of energy emitted. The amount of energy emitted per unit area into per unit time. For n number of photons, it would be I is equal to NE by T. Okay. When from this it is very clear that I is direct proportional to N. When intensity is increased, the number of electrons emitted is also increased. When the number of electrons are increased, what happening is there? Photoelectric current also increase. Is it clear? When we have drawn the graph across what is that? Across photoelectric current and intensity of incident light, so which is gives what is that? This is the intensity. Intensity you can take intensity on, you can take intensity on x-axis, intensity I on x-axis, and photoelectric current on y-axis. Okay. When the intensity is increased, what happening is that emission of electrons are increases. when the emission of electrons are increased from the cathode, what happening is that the flow of the current in the circuit is also increased. That means the intensity is direct proportional to N. Simply what I am writing, intensity is direct proportional to N is direct proportional to photoelectric current. Okay. Simply, finally, it is concluded that I is direct proportional to I. The intensity of light is direct proportional to photoelectric current. That means, what is the shape of the graph? The shape of the graph will be gives a straight line. No, I intensity is direct proportional to photoelectric current. Okay, this is the shape of the graph between I and V, which is gives a straight line. The slope of the graph is given by tan theta. What is the tan theta? Tan theta is equal to what is that? This is I have taken I. This is also would be I, and this is intensity. This also would be intensity only. Therefore, tan theta is equal to what is that? Electric current, photoelectric current upon what is that? Intensity of light. Intensity of light. Simply what I am writing, tan theta m is equal to tan theta is equal to I upon capital I. So this is a slope of the graph. This is the effect of an intensity of light on photoelectric effect. Is it clear? Is it clear or not? Respond. Is it clear or not? Respond. Okay. Next, see effect of here. See what is this? Okay. Here see today class see dual nature of radiation. What is the photon and photon mass and wavelength. Wavelength we have calculated like this, and momentum, force exerted by the photon on this. Next see, and intensity of light like this. Next intensity varies with respect to radius like this. Next see, this is a photon flux. The photon flux would be is equal pi is equal to I upon E, that is called P upon E, that is called to what is that? Pi is equal to E upon 80 into E. E gets cancelled 1 by 80. If the area and only time given, we have to calculate like this. If the what is that pressure, power and lambda and A and HC given, we have to calculate like this. Okay. Next see, the calculation of energy of photon. The calculation of energy of photon would be like E is equal to 12,400 in electron volts by lambda in angstroms. Because of E is equal to H nu, that is SC by lambda, that is 12,400 electron volts upon lambda in angstroms है बेटा. So find the energy problem दिया ऐसा करना पड़ता है. Next see, one more problem see, a photon of mass m possesses the energy which is at the height of h and falls on the ground. Then calculate the change in frequency. वो भी निकालना पड़ता है. Here how we will calculate the what is the change in frequency in this case? See, we had applied law of conservation of energy. ui plus ki is equal to uf plus kf. इसमें fl आ गए. ठीक है. Next to see one problem. Next one is a photoelectric effect. This is very important for JEE Mains and advanced के लिए. It was discovered by Smith and Hatch in 1987. This mechanism also looking like is there. Okay, electrons are freely moving around the nucleus with the nuclear attraction force. When a suitable wavelength or suitable radiation of light is incident on the metal surface, what happening is that electrons are ejected like this. Okay. Do you have any doubt? Today concept, please contact on scrolling number. Hello. Do you have any doubt to the concept? On to the concept, do you have any doubt to the concept? Please contact on the scrolling number.
సో ఇప్పుడు స్టూడెంట్స్ ఎంతసేపు మీకు డౌట్స్ ఉన్నాయని చెప్పి చాట్ బాక్స్లో పెట్టారు కదా. సో మీకు ఇప్పుడు ఏ డౌట్స్ ఉన్నా కానీ దయచేసి మీ స్క్రీన్ పైన ఒక నంబర్ స్క్రోల్ అవుతుంది. సో ఆ నంబర్కి కాల్ చేస్తే సార్ మీకు డౌట్లు క్లియర్ చేస్తాడు. ఇంతకుముందు చాలామంది చాట్ బాక్స్లో డౌట్స్ ఉన్నాయని అడిగారు కదా. సో ఇప్పుడు మీ డౌట్స్ ఏమేమి ఉన్నాయో మీరు నోట్ చేసుకున్నారు కదా. సో తరుణ్ నాయక్ అని చెప్పి, లేకపోతే ఇంకా చరణ్, కొంతమంది కామెంట్ చేశారు. సో ఇప్పుడు మీకు మీ డౌట్స్ ఏవేవి ఉన్నాయో దయచేసి మీరు నంబర్కి కాల్ చేయండి. మేము మీ నంబర్ ఏదైతే నంబర్కి కాల్ చేస్తారో ఆన్సర్ చేసి సారు మీకు డౌట్లు క్లియర్ చేస్తాడు.
Okay. Okay. Dear students, please do you have any doubts on today concept? Ask me.
హలో,
హలో
మీ స్కూల్ ఏంటి? మీ స్కూల్ ఏంటి? మీ పేరు చెప్పండి, క్వశ్చన్ అడగండి.
హలో
హలో, మీ చెప్పండి.
సార్ ఎంసీపల్లి కాదు. హలో
చెప్పండి, డౌట్ అడగండి.
ఫోటో ప్రోటాన్ ఫ్లక్స్ లో డౌట్ ఉంది సార్.
చెప్పండి, వాట్ ఈస్ యువర్ డౌట్?
ప్రోటాన్ లో ఏదో డౌట్ ఉందని అడిగాను.
Photoelectric. Hello, please ask me your doubt. What do you have?
ప్రోటాన్ డౌట్ అన్నారు. నెక్స్ట్ క్వశ్చన్. సార్ మీకు నేను చెప్పినాక 5 seconds డిలే ఉంటుంది.
Okay.
మీరు దాంట్లో వచ్చినాక ఆన్సర్ చెప్పండి.
Okay.
హలో
చెప్పండి, మీ డౌట్ చెప్పండి.
సార్ ప్రాబ్లమ్ లో డౌట్ ఉంది సార్.
అడగండి, మీ డౌట్ అడగండి.
సార్ ప్రాబ్లమ్ when a photon fallen on the ground ఉంది కదా సార్.
Yes. హలో
సార్
హలో
సార్ లాస్ట్ స్టెప్ లో హెచ్ఎఫ్ డాష్ ఈక్వల్స్ టు హలో సార్ హెచ్ఎఫ్ డాష్ ఈక్వల్స్ టు E/C² into GH ప్లస్ హెచ్ఎఫ్ కదా సార్.
మీ క్వశ్చన్ ఏదో గట్టిగా లౌడ్గా అడగండి, కట్ అవుతుంది మీ వాయిస్.
ఓకే, ఐ కెన్ ఎక్స్ప్లెయిన్ వన్స్.
లాస్ట్ స్టెప్ సార్.
ఏంటండి
లాస్ట్ స్టెప్ సార్.
లాస్ట్ స్టెప్పా?
దిస్ వన్.
ఏంది లాస్ట్ స్టెప్? ఏంది అది?
లాస్ట్ స్టెప్ హెచ్ఎఫ్ డాష్ ఈజ్ ఈక్వల్ టు
ఎఫ్ డాష్.
ఎఫ్ డాష్ అదే.
ఎఫ్ డాష్. అవును సార్.
ఓకే, అది ఎక్స్ప్లెయిన్ చేయాలా?
సార్ హెచ్ ఆర్హెచ్ సైడ్ వచ్చింది కదా సార్.
హలో
సార్ హెచ్ ప్లాంక్ కాన్స్టెంట్ కదా సార్.
ఎస్ ఎస్, హెచ్ ప్లాంక్స్ కాన్స్టెంట్. ఇట్ ఇవ్వండి, ఇవ్వండి. ఏం కనబడుతుంది? హలో
సార్
చెప్పండి. హెచ్ ప్లాంక్స్ కాన్స్టెంట్. ఎస్
హెచ్ ప్లాంక్ కాన్స్టెంట్ ఆర్హెచ్ సైడ్ వచ్చింది కదా సార్.
ఎస్ 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 ఎస్. చెప్పండి చెప్పండి. హెచ్ ప్లాంక్స్ కాన్స్టెంట్స్ విల్ హ్యాస్ టు గట్ దిస్ సైడ్. ఇక్కడ చూడండి, హెచ్ఎఫ్ డాష్ ఈజ్ ఈక్వల్ టు E/C² into GH ప్లస్ హెచ్ఎఫ్. ఇజ్ ఇట్ క్లియర్? హెచ్ని ఏం చేసినాం అంటే తీసుకొచ్చినాం, బై తీసుకొచ్చేసినాం. ఎం ప్లస్
హెచ్ ఆర్హెచ్ సైడ్ వచ్చింది కదా సార్.
ఎస్.
ఫస్ట్ టర్మ్ లో E/C² into GH అనేది హెచ్ అనేది హైట్ కదా సార్.
ఎస్ ఎస్, కరెక్ట్ 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 కరెక్ట్. ఎస్ కరెక్ట్.
ప్లాంక్ కాన్స్టెంట్ విల్ నాట్ గెట్ క్యాన్సిల్.
ఎస్ ఎస్, కరెక్ట్ 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 కరెక్ట్. యూ షుడ్ రైట్ యాజ్ ఇట్ ఈస్. ఓకేనా?
ఓకే సార్.
రైట్ రైట్.
And one more doubt, sir.
టెల్ మీ.
P is equals to 200 watts question, a light radiation with 200 watts.
1 minute. Okay. Tell me.
Sir, last step, n by T equals to 4 into 10 power 20 kada sir.
Yes, 4 into 10 power 20, right.
In the place of P also you have substituted 4 into 10 power 20, sir.
N by T was given, no? Here we have to calculate what is that. P was 200 watts given, no?
Sir, n by T is equals to 4 into
Yes,
10
yes,
power
correct,
20.
correct, correct. In that also we should have to calculate the P value. P is got 200 watts.
Yes, sir. You have substituted 4 into 10 power 20.
Okay. This is instead of this one, you can put to 200 watts.
Okay.
Okay, now?
Okay, sir.
Is it clear?
Okay, sir. Thank you, sir.
Okay.
సార్, నేను ఎందుకు ఈ హెడ్సెట్ ఇచ్చానంటే మీరు
ఓకే, కట్ అయిపోయిందా?
కట్ అయిపోయింది. ఇక్కడ నేను ఎందుకు మీకు హెడ్సెట్ ఇచ్చానంటే లైవ్ కట్ కాలే, క్వశ్చన్స్ అడుగుతున్నారు, ఇంకా ఫోన్ చేస్తున్నారు.
నేను వెళ్ళాలి మరి కాలేజ్కి. ఓకే.
హెడ్సెట్ ఎందుకు ఇచ్చానంటే మీకు,
ఓకే,
మీరు చెప్పేది ఈ లైవ్ ఈ మాట్లాడేదాన్ని బట్టే కంటెంట్. ఇక్కడ వాయిస్ ఇక్కడ క్యాచింగ్ మీకు సంబంధం లేదు.
ఓకే.
ఎందుకంటే ఇక్కడ నుంచి ట్రాన్స్మిట్ అక్కడికి ట్రాన్స్ఫర్ కావడానికి వాయిస్ క్యారీ కావడానికి ఒక 5 సెకండ్ 10 సెకండ్ డిలే ఉంటుంది.
ఓకే.
అప్పుడు నేను ఈ స్పీకర్ ఆన్ చేసి ఇక్కడ ఎందుకు పెట్టానంటే ఇక్కడ మాట్లాడింది మీరు ఇక్కడ ఎక్స్ప్లెయిన్ చేసేది మ్యాచ్ అవుతుంది.
ఓకే.
సో మీకు
ఎందుకు స్పాంటేనియస్గా వాళ్ళు అడుగుతుంటే స్పాంటేనియస్గా నాకు రాదా?
స్పాంటేనియస్గా మీరు వెళ్ళేది లైవ్లో స్పాంటేనియస్గా వెళ్ళదు కదా మరి. అప్పుడు
ఎందుకు ఆల్రెడీ లైవ్లో ఉన్నాం కదా సార్.
సార్ మీ లైవ్ వెళ్ళేదే 10 సెకండ్ల గ్యాప్ తో వెళ్తుంది.
డౌట్ సార్కి అర్థం కావాలి కదా.
వాళ్ళ డౌట్ అర్థం కావడానికి వాళ్ళు అడిగింది నేను ఇక్కడ పెడుతున్నాను. అది సార్కి సార్ లైవ్ తోటి మ్యాచ్ అయి వినబడుతుంది. అంటే ఒక 10 సెకండ్ల గ్యాప్ ఉంటుంది.
ఓకే,
మీ 10 సెకండ్లో గ్యాప్ లో మీరు చెప్పింది వాళ్ళకి మ్యాచ్ అవుతుంది.
అంటే ఇప్పుడు మనకు టైం ఇట్ విల్ బి టేక్ సమ్ టైం.
yes 10 సెకండ్స్ పక్కా గ్యాప్ ఉంటుంది ఎక్కడైనా.
ఓకే ఓకే ఓకే.
మళ్ళీ మీరు అది విని చెప్పడానికి కోసం మీ కాడికి రావడానికి 10 సెకండ్లు పడుతుంది.
ఓకే ఓకే.
మళ్ళీ మీరు చెప్తే 10 సెకండ్లు ఆగిపోతుంది.
ఓకే.
టైం కన్స్యూమింగ్ ఉంది.
సెకండ్స్ అంతే,
10 సెకండ్స్. ఓకే.
అప్పుడు ఏమైతుంది, మీరు ఇక్కడ ఇప్పుడు ఎక్స్ప్లెయిన్ చేసినప్పుడు ఫోన్ టక్క చెప్పేస్తారు.
ఓకే.
వాళ్ళకి అది వెళ్ళడానికి 10 సెకండ్లు పడుతుంది. అందుకోసం మీరు ఇది పెట్టుకొని చెప్పడం వల్ల ఏమవుతుంది అంటే వీళ్ళు అడిగిన క్వశ్చన్ కి అది మ్యాచ్ అవుతుంది, అక్కడ మ్యాచ్ అవుతుంది.
ఓకే.
అది చేయాలంటే ఎట్లా స్పీడ్
స్పీడ్గా లైవ్ రావాలంటే ఎట్లా టైం
స్పీడ్గా రావాలంటే ఇంకా పెద్ద ఇంటర్నెట్ స్పీడ్ ఉండాలి. అంత కాదు, వాళ్ళకి అక్కడ కూడా ఉండాలి మన స్పీడ్.
ఎస్
కూడా అంతే ఉంటుంది. మినిమం 3 సెకండ్స్ 4 సెకండ్స్ గ్యాప్ ఉంటుంది జూమ్ లో కూడా.
ఓకే ఓకే. ట్రాన్స్ఫర్ కూడా. ఓకే.
ఎవరు ఈ డౌట్ ఇచ్చే ప్లాన్ పోవాలి మళ్ళీ.
మీకు ముందు చెప్పాలి కదా ఇవి.
క్లోజ్ చేయండి. క్లోజ్ చేయండి.
ఒక క్వశ్చన్, లాస్ట్ క్వశ్చన్.
సరే.
హలో
చెప్పండి అమ్మా.
సార్ మాకు ఫోటాన్ ఫ్లక్స్ అంటే ఒక డౌట్ సార్. ఫోటాన్ ఫ్లక్స్ అంటే డెఫినేషన్ అదేంటి సార్?
The ratio of intensity of photons to its total number of energy is called as photon flux. Flux అంటే ఏదమ్మా, the number of the beam of photons traveling. No, the combination of beam of fluxes is called as the combination of beam of photons is called as a flux. Flux అంటే మనం జనరల్ ఎలా డిఫైన్ చేస్తాం చూడండి. This is a flux. Beam of photons. This beam of photons are traveling, like this.
మళ్ళీ ఒకసారి
చూడండి అమ్మా, ద బీమ్ ఆఫ్ ఫోటాన్స్ అంటే ఒక బీమ్ అంటే ఒక రే ఆఫ్ లైట్ లో మనకి ఎన్ నెంబర్ ఆఫ్ ఫోటాన్స్ ఉంటాయి. ఉంటే దాన్ని ఏమంటారంటే బీమ్ అంటారు. ద కాంబినేషన్ ఆఫ్ ద బీమ్ ఆఫ్ లైట్స్ పాసింగ్ త్రూ పర్ యూనిట్ ఏరియా పర్ యూనిట్ సర్ఫేస్ ఈస్ కాల్డ్ యాజ్ వాట్ ఈస్ కాల్డ్ ఫోటాన్ ఫ్లక్స్. ఎస్ కరెక్ట్ మేడం.
ఓకే సార్, థ్యాంక్ యూ సార్.
ఓకే. రైట్. ఓకే, థ్యాంక్ యూ. నేను మళ్ళీ పోయినా మీరు రాయండి నాకు.